Hi everyone, welcome to STEAM Quest number 7 this week. We have wonderful co-hosts today, Ali from Turkey, Omash from UAE, Indrajit from UK, Vasisht from UAE, and Cameron from UK. As always, Professor Sunday from Imperial College is with us, and Lara and me from Twin Team. So that's great to have you guys today in here, and to all YouTube viewers from the show, we say hi. We started the show with a short movie of Twing mobile application, and the number of experiments, challenges inside of the application is increasing day by day. And we have some of like sample experiments that we want to show you. I don't want to take your time too much, but I find one is very sweet and very nice. I will show one experiment from one of our users, and her name is Cindy. And let's watch it together. She tries to make her own fire extinguisher. Let's watch together.
Guys, this is baking soda and this is vinegar.
And then we are going to blow out these two candles with just these two things.
Instead of like blowing like.
Ready? So pour in the vinegar. Yep, inside. Ready? Now we're gonna take this. See? And we didn't even touch it.
Yeah.
Cool?
I want to try it again. I want to try it again.
I also want to try it again every time. So that's understandable, Cindy. Thanks for sharing. We are waiting for your videos, and we will try to show these videos at the beginning of the show in here. And there are hundreds of challenges. Please go check it out, and we will be looking forward to your videos. So before starting the show, Sunday, maybe you can tell a few words.
Yes. Can you hear me? Okay. Hi, guys, everybody. Welcome again to week 7 of our Quest Challenge, Creative Future Quest Challenge in partnership with Twing and Imperial College, and as well as the Academy. This is our 7th week, and it's going very, very strong. And I could see people already joining us from all over the world: Nigeria, Singapore, Jamaica. I could see Ghana there, and I could also see Trinidad and Tobago. So you're all welcome. It's gonna be fun. We always have fun every single week. And I thank all our co-hosts, the young guys that are with us today. Very, very clever people. And I'm sure you guys, if you want to be a co-host, just get in touch with us. We'll bring you along so you also have the same experience. So Lara, let's take it away. Cameron, welcome.
Yes, so I would like to know you a little bit. So let's start with Ali first. Yes. How old are you? What do you do in your free time?
I'm 13 years old. I live in Turkey. I actually play video games at my free time, not actually all the things.
That's understandable during the pandemic. Yes. So next, Cameron.
I'm Cameron, I'm 12, and I like to go outside and play sports.
That's nice. Okay. Indrajit, it's your second time in our show, right?
Yeah, this is the second time, yeah.
Thanks for attending once more.
Hello, my name is Indrajit. This is my second time, and my favourite subject is maths and science, and I quite like cricket and table tennis.
That's really nice. Omanj.
Hello, I am Omansh. I am 9 years old. I am 9 years old, and I really like science. It's my favorite subject. I really like maths also. I study in Sharjah Ambassador School in UAE.
That's nice.
Just
Okay. And Wasish? Let's know a little bit
okay.
more.
My name is Vasisht. I'm 9 years old. So my favorite subject is science and maths.
Okay.
I am from Sharjah Ambassador School.
Okay, that's really nice. Are we all excited about today's show? I want to
Yeah.
see hands.
Yeah.
Are we excited?
Yeah.
Okay, so our first question comes.
So just for our YouTube participants, you can also write your answers through live chat window at the right side in the given time to you. And at the end of the show, we will give away 3 Twin Science kits to the ones who answers in the fastest and most accurate way. So we will give one robotic art kit, one curiosity kit, and one coding kit to 3 YouTube participants today. And this is just a reminder. Please try to follow through and answer from live chat in the given time to you. Okay, Lara, I will shoot the first video.
Okay, and our co-hosts, please don't forget to write your answers in the chat below so that we can look at your answers all at the same time. Yes, okay. So our first video comes. I want one person to tell me what's going on in this video, and I think that could be Indrajit.
It's
Yes,
the
what?
Earth, and
Yes,
and it's rotating, and it's orbiting the sun.
exactly. Okay. So
Um,
what shape does it create while orbiting?
it's an elliptical orbit.
That's correct. Okay, I think this video doesn't really have it, but so how do you think our Earth orbits around the sun? Like, is our sun just stable or is it moving? Does anyone have any idea about this? Hands, maybe we can see hands. Yes, Omansh?
I think that like when the Earth is moving around the sun, I think so. It's actually, the simple thing. It's actually rotating around the sun.
Yes, that's true. But is the sun stable? Like, is it at the same time? Is that like the same place all the time?
Well, you know that the sun is faster than the Earth actually.
Yes.
That's why the Earth. That's why the Earth takes 365 days to complete 1 year.
Yeah, but what I was
And
actually
this video is actually telling about the rotation only, but the movement of it, the movement, how is it moving and all.
yes, so like the Earth orbits around itself and around the sun orbits around itself too, but we know that the sun is also moving with a velocity. So the Earth orbits around the sun and our sun also has a velocity and it's moving. So this means that they're performing like a helical shape. And our next question is actually about these orbits, orbital speeds and stuff. So I think we can have it and talk about it more after the question. Okay. Earth's orbital speed around the sun is 107,208 kilometers per hour. Why does an observer on Earth feel this? A, the observer is numb. B, the Earth is still. C, the Earth is very little. D, the size of the orbit is relative. We have 10 seconds. Okay, so we got the answers and they're all the same. So I want one person who said D to explain to me why did he or she said that. So maybe it could be, yes, Cameron.
I said that because of gravity, there is no possible way of us feeling us moving around. So it all attracts to the center of the earth. So there would be no possible way of us feeling us just floating around.
Okay, so you said that we have gravity, so we don't really float around the space, and
Yeah.
that's why we don't really feel what's going on. Okay, we might have like some other opinion, maybe Indrajit or Ali. Do you have any idea about this? Why did you say B?
Can I see the question again?
Sure. So did you use like the elimination method, maybe a little?
Because I knew the Earth isn't still because it spins around its axis.
Exactly.
Yeah, and I don't think so. It was the observer's numb, and yeah, and the Earth was very little because it's quite big.
Yeah, it's big for us, but in our galaxy it's really little, so it's relative, right? So, does anyone know what relativity actually is in like very, very simple terms? Does anyone have any idea? Relativity.
Doesn't mean like the same.
Sorry, what?
The same.
Yes, but like on our Earth, do we see any situations that we came across relativity? Like while we're in our room, maybe, or while we're in a car. Do you know anything about that? Omash, do you have any idea?
I didn't hear the question correctly.
Okay, so let me repeat it one more time. I asked, like, did you ever experience what relativity really is while you're on Earth? Like maybe you're in a car, or you're in your room, maybe you're walking. I don't know. Think about it as like speed. Okay.
For example, sometimes classes might feel like longer than it is, right?
Yes.
Sometimes you don't have enough energy. Sometimes you cannot focus, and especially at those times, time slows down, right? A little bit. At least you feel like it. Have you ever experienced this? Any one of you? No?
Yes, definitely
Yeah.
me.
Ali, Ali jumps in. Yes, Ali. How was it?
I think so. Sometimes I experience.
Omansh as well.
I don't actually remember.
It's fine. Yes. Yeah, that's a really, really good expression to understand relativity in terms of time. But what I was talking about was about speed. So I'm gonna ask in like much simpler terms. Let's say you're in a car. You're going with 50 kilometers per hour speed. And there's another car next to you, which is going with the same, like exactly the same speed. How would you see that car? Cameron, do you have any idea? Yes.
Not moving at all. It's just next to you. It would appear as if it's not moving at all, but realistically, it's going very fast to a standing still person.
Exactly. This is what I was talking about. If we were an observer on Earth and we were looking at those two cars, we would see that they were going really fast. But like two people facing each other in those cars would see them not moving at all. So it just depends on where you are actually, not what's really happening around you. So the point of view, the frame, where the observer is the key in this kind of thing. So in our situation, we know that the Earth revolves around the sun with 107,208 kilometers per hour, and I wrote that next to my notebook because that's a huge, huge number to remember. So, and I have another question. Do we know how much distance Earth covers in 1 year? I want to take guesses. In kilometers. What could be like the distance of the orbit? Earth's orbit. Just guess.
Just guess. Wildly guess.
2,000 kilometers. 50 million kilometers.
30 million kilometers.
Okay, we got 30 million kilometers. I'm going to choose the closest one.
I guess 15.
15 million kilometers?
Yeah.
Okay, we got 15. Ali, do you have any idea?
I was gonna definitely say 15 million kilometers.
Okay, we got 2 15 million, 1 30 million. Wasish?
15 million millimeters.
Millimeters.
Just
Yeah, he's playing with numbers.
Okay, it's fine, it's fine. We got 15 million millimeters to 15 million kilometers in Cameron.
Is it per year or per
Per
day?
year. Yes,
Per year. I would say about 30 million kilometers.
30 million. So it's either 30 million kilometers, 15 million kilometers, or 15 million millimeters in 1 year. But I think you're going to be shocked that it's 940 million kilometers in a year. So that's the distance of our orbit. It's huge, and we know that that per hour is 107,208 kilometers. So when we do like a little simple math, and we use and we use that to find the relative velocity of us, we see that it's like 4.3 centimeters per second. So let's watch this video. What do you see, Ali?
I see Earth orbiting around the sun and the moon orbiting the Earth.
Yes. So, and the sun again. So, yes, this is a visual of it. So this is like huge numbers going on, and we don't feel nothing at all. So I think we did not give the correct answer, but I believe you can all guess it right now. We all talked about relativity and stuff. The size of our orbit is relative when we think. It varies according to the observer. For someone on Earth, we don't feel at all. Someone on Jupiter, I don't know how would they see, but it'll be different, I'm sure. So it's all about the relative size of our orbits. Yes. Did you like this question? Not really. Okay. We got the camouflage question. Everyone loves that. So next question is camouflage. Let's have the image. Okay. Again, this is a warning. If you see something, please don't yell it. I always say this, but it never really happens. So I just want to say, like, here's some basic things. Like, what do you see in the image? Very vaguely. Yes. Okay. Cameron? Cameron? I think you're muted.
Flowers.
Yes, flowers. What kind of flowers? Do you know it?
No.
No.
Well,
Okay.
every question has a frog camouflaging.
You're right. You're right. Ali, I see your hand.
It looks like an orchid.
Yes, exactly. It's a white orchid, and there is an animal hidden inside. But let's ask our question first, and then talk about this. So. Which animal is doing camouflage in the image above? A butterfly, a mantis, a bird, or a caterpillar? You have 10 seconds. Okay. So we got A's, 1B, and a question mark. Okay.
Oh, I was supposed to put C.
Okay, it's fine. You can still put it. It's fine. So we got A's, B's, 1C, 1B, mostly A's. Okay, so let's take a closer look at the image. Well, for example, the people who said A, a butterfly, where do you actually see the butterfly? Who said A? Let's see. Wasish, where did you see the butterfly?
So I saw it like there.
Where?
little side.
To the right?
More side, like to the corner.
The corner. Upper left corner?
Like
Lower
that,
left?
like that. Little up.
There?
It's
This
right
is
there.
right there? Where?
Not there. It's up there.
Up.
Yeah.
Okay.
Right, little side, yeah.
You see there?
I think I see it there.
Okay, it's fine. Do we have any other answers? Like a different, like Indrajit, you said C. What was the option C? A bird. Where do you see the bird?
Well, I think so. I think
if
so.
you-
The black part of the orchid is really suspicious.
Yeah, that's the
Okay.
part I said it was the bird.
Oh, okay. So you say that that little part is a suspicious one. We don't really know what it exactly is. Okay. Is it time for? Okay, Ali, yes.
It looks like a mantis.
A mantis?
The
You
right
actually?
part of the right orchid. Yes,
Mm.
that place.
That
Looks
part?
like the mantis.
Okay, so do you know what actually a mantis is? Like the actual, like, etymology of what a mantis is. Does anyone know? I didn't know before this question, so it means a prophet. Yes. Ali, I think you did you Google it up?
No, I just know it from like Kung Fu Panda.
Oh, yes. Was it a mantis? Yes.
Ah,
Yeah,
There
those
was
are
a
yes.
this
mantis.
in Kung Fu Panda. Nice
It
one.
is.
Nice one.
Oh, yeah. Yeah. I completely, yeah, I did not remember that. So, yes, the one that's hidden is a mantis. It's the option B, but now we're gonna see where it exactly is because it's super, super hard to see. Let's watch. Okay, so we got white orchid, right? And this is our picture. Yes, that little circle. Like, even now, I can't really see it. Can you? Like, until it moves, I can't really see. Like, yeah. So that little part, yes. Like that little black part is like the head, but it blends so perfectly with the orchids that it's even impossible to see like this close. Yes, that's the body part, head. So, do we think that like does all mantises are white? Yeah.
Okay.
You're all white or not?
Do they camouflage?
Yeah, they do camouflage.
They're not all white because if they can change color to another color.
We're like flowers have lots of different colors: pink, orange, white, brown. So these mantises can blend perfectly with orchids, especially. So let's watch this one. It's not white as you see. It's like a little pinkish, yeah, whitish pink kind of thing. They're beautiful, but it's super hard to see. And they got like the same structure of.
It's a mantis. Yeah, it's a mantis.
Yes. And this is like a pure pink one. Yes. And they're like so fragile, isn't it? Like you can hurt them really easily. It looks like that. Yes.
But Lara, why they are called mantises? You were going to explain that.
Yes, I forgot that. I'm sorry. Yes. Perfect reminder. So they're called a mantis because in ancient Greek, a mantis was called a prophet, which is like someone who's the leader of a religion. And this looks like it's praying, like when, like for example, Muslims pray, they do like this.
Mhm.
So this looks exactly like this. So they call the prophet or like a mantis in ancient Greek. This video is really interesting. Please look at it with close attention. Okay. So we got our little mantis bothering the other one, and they fight. I have a question. Which one is the female? Which one is the male? Just take a guess. Ali, yes.
I think the big one is female.
Why is that? Like, I'm like, how do you know?
I don't know. I just guessed.
Really? Okay. So mostly like people think the male ones are always like bigger ones in like in terms of like shape. But here we see that the male mantis is actually in terms of like the size, the half of the female one, which is really interesting. So if you see a bigger mantis, it's probably female. Just keep in mind. Yes, and these are another picture blending perfectly with the orchid. It's really nice. Did you like the camouflage? I think it was really hard though.
Yeah, it's pretty hard. It was pretty hard. I know there's a mantis there, but I was not able to locate the exact place.
Yes. Okay, so here comes the third question. Okay, I want who? I need to tell me what's going on in the video.
Me.
Yes, let's watch.
Equator.
Yes. Let's stop for a minute. Yes. So do we all know what the equator really is? Have we ever heard of it?
Yes.
Like, what comes to your mind when we say equator?
Hot.
Indrajit?
Very hot.
Hot. Okay.
It separates the northern and the southern hemisphere.
Perfect. So it's like a imaginary little middle line on Earth, right? Yes. Does anyone have any other thing that they know about the equator? Omanj, is that your hand? Yes. Were you gonna say something?
Yeah, I was going to say something.
Okay, yes, here, just go.
Can you show the presentation again?
Yes.
The equator is actually the northern southern part. Like it's almost between like the middle of the earth, but it's just what do you call it? A little bit down.
So it separates it. Yeah. Okay. Any other do we know what kind of plants are in there? Like how does a place on the equator look like? Is it like dry or moisturized? Like
It's quite dry.
say dry. Okay. Does anyone have any idea? Vasish, we didn't hear from you for a long time. What comes to your mind, Vasish, when we say equator?
What comes to my mind is like, just wait a minute. I just know the answer.
Okay, it's fine. And you're Googling it?
No.
Okay.
Guys, what is your favorite fruit?
Fruit. Passion fruit.
Mango.
Passion fruit. Omanj, what did you say?
Mango.
Okay. Ali?
Strawberry.
Strawberry. Okay. Ali's fruit is here. Okay. Wasish?
Mango.
Mango. Cameron?
Peach.
Pig, you say. Okay,
Peach.
pig goes to here. So what is common about mango, passion fruit, and my favorite one, which is banana? What is common about these three fruits?
Well, they just taste.
Very nice. Very nice.
They're sweet. They taste good.
Yeah.
Mine is melon.
Melon.
Thanks for asking, Jihan.
Yeah. Sorry, Lara. Okay. So
It's
guys,
fine.
these all three fruits are from tropical climates.
Yes.
What does tropical mean?
Sunny.
Sunny.
Yes.
Okay. Lara, maybe you can.
I mean, there might be like jungles, maybe.
Yeah.
That part. So here it says Tropic of Cancer, which is 23.5 degrees up from the equator. Okay, let's watch the video. And another 23.5 degrees in the south, which is the Tropic of Capricorn. These are just regions on Earth, and we call it the tropical region. Okay, so let's stop for a minute. What images do you see? Like those little photographs? They're from this region, this tropical region. Cameron,
I think so. An island.
yeah, an island. Yeah, it might be an island. It depends on the land. Yes.
I see like a beach and islands and all.
Yeah, sunny beach, islands, and there's a jungle. So, Cameron, you said dry, but maybe it's a little bit more moisturized than being dry because it rains really much there. Yes? No? Cameron?
Yes.
Okay.
My voice is gone.
Okay, it's fine, it's fine. So we got the tropical regions, and when we go up, 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 it's the Arctic Circle, and we got another Arctic Circle, and those the top and the bottom regions that's highlighted right now, they have 4 seasons. For example, I live in Turkey. We have 4 seasons, even though because of the climate change, we can't really see them perfectly. For example, it was still raining and it's like June in here. It's supposed to be like really dry and hot. So the climates are changing, but we have 4 seasons. For example, do you have 4 seasons in UAE?
Wasish, Omash, you are muted.
The normal seasons. Spring, summer, seasons.
Yeah, Indigit.
In India, I know there's 6 seasons.
Oh.
There's the monsoon season. I don't know about the other one, but yeah.
Oh, interesting. So seasons do change according to where you live on Earth because of the sun. So our next question.
Yeah. Monsoon and autumn. Autumn.
Okay.
Yeah, there's another one as well.
Yes. Let's continue. And yes, so our next question is about this equator and the equator being really hot. So let's read it. Hottest place on Earth is the equatorial region. What is the reason for this? A, there are many volcanoes. B, it takes sunlight with a steeper angle for a longer time. C, Earth's magnetic field. D, air pollution. You have 10 seconds. Wow. So the time is up, and I got the answers, and they're all the same. Okay, so we all think that it's B. Someone who said B. Any one of you. Yes, Indrajit. Why do you think it's B?
So it's right above because it's in like a steeper angle.
Okay.
Yeah, and so basically, if it's summer in the northern hemisphere, it's normally winter in the southern hemisphere. But if you're in the equator, it doesn't really matter because you're in the middle.
Then why is that? Why does it really matter?
Is it because the sun will be at the literally in the top all the time?
I don't really quite hear you. Can you say it one more time, please?
Is it because the sun's like straight up in this sky?
Yes, it's because of the orientation of the Earth and the sun. So how is sun rays coming to the equator? Like, for example, what angle? Straight, tilted, what do you think? Cameron, yes.
It's coming at a tilted angle to allow which allows sunlight to get trapped in there and makes it much hotter as all the ground pretty much takes in all the heat and reflects it out and makes it much hotter.
Okay, so you think that it's taking most of the energy coming from the sun. Yes. What did you say?
Yeah. He said correct because it comes in a tilted way because when the Earth rotates around the sun, it doesn't only rotate in the single direction, it rotates different directions. So that's why the sunlight comes on every way. It comes tilted.
So we know that the Earth is tilted, and we're looking at how the sun rays are coming to the Earth. So we can make it like a little comparison, but I have a video about that, which we can compare the temperature on the Earth in like different places. So we got this, yeah, we got this imaginary globe, which has thermometers on it from like at different places. So this one that's right on the middle is very, very hot. And the one at the little bit top is a little colder, right? Yes, so we can stop, I think. Yes. So here we have this, our heat supply on the right, which is acting just like our sun. How are the sun rays coming at that like middle point? Tilted or directly? What do you see in the video right now when we look at the middle line? Ali? Oh, yes. Ali, do you have any idea?
They're coming by waves. They can actually change directions, but it always hits the surface.
Yes, they hit the surface. That's correct. Omash, I think you were saying something.
No.
No? Okay. Fine. Cameron? Like, when we compare those waves, how's it coming to the like northern and southern hemisphere and the equator? Like, what's the
It's
difference?
further away from the northern and southern hemisphere as it is a sphere, which makes it closer to the sun as the middle, as that attracts all the heat before it finally reaches when it's gotten colder through the air, the northern and southern hemisphere.
Yes, but in this video, actually, it was saying in the back that rather than being close to the sun, it's about the angle because our Earth is not flat. It's not like a square or something right in front of the sun. It's a globe. So we have like a middle part, which is, it seems like it's closer to the sun, but it's about the angle since we're like a circle shape. Yes. So at the equator, the sun rays are coming directly, which creates the reason for the equator being hot. It comes with a steeper angle. So we got that part, and we can actually even see it with this very, very basic experiment. So we got this video. Please pay close attention. Can someone say what they're seeing? Indrajit, maybe you can?
They're drawing a circle.
Yes, according to what?
Wait.
Yes. What were you gonna
They
say?
are actually taking a torch first. They are putting like this, and then they are like measuring the light, and they are putting a circle around it. And when they are doing from another angle like this, it's much bigger than the last one.
Yes, so we got a torch. We're gonna say something different, Indrajit? What were you gonna say?
Yeah, I was gonna say it's because of the different angles of putting the torch.
Exactly. So the important part is our torch never changes. So the energy, the light, or the heat, like both of them, coming from the sun, the energy is always the same. But as the angle increases, like that, like when we put it like this, it's all concentrated in that circle. But when we tilt it a little, which is like this, the area increases and all that energy actually spreads, which makes the northern, like the Arctic poles, much colder than the equator. It's all about the angle that those places are taking the sunlight. So don't forget that the energy is always the same. Okay? Does anyone want to say anything about this? Yes. So can someone like summarize a little what we've just discussed? Ali, maybe you?
When the like sun rays as the picture shows that the sun rays go further away, its energy lost, like lowers.
Yes, because it spreads in a bigger area. The amount of energy that's directed there in like a unit changes, it decreases. That's correct. And in a smaller area, the energy is the same, but it does not really spread around. It's just that circle. So we got that one, got it from our way, and we got the most interesting question, which is the illusion. So let's watch our
Are you
illusion.
ready, guys? Are you ready for the illusion one?
Yep.
Thumbs up.
Okay.
Okay, here we go. Okay, so we got this man.
Wait. Is this America's Got Talent?
Yes, it is. Okay, do we see what the like? Cameron, can you explain what you've just done? Maybe we can rewind. a little.
Somehow he has put his some salt into one hand and it's
I
come
know,
out
I
into
know.
the other hand.
Yes. Go, Cameron. 1 second, Omash. Yes.
It's somehow come out the other hand back. So he puts it in one hand, he blows on it, then he points at his other hand, and somehow it all comes out.
Okay. So we've done that with salt, and now with liquid. Yes, Omash. Now we can say.
You know what he's actually doing? When he like closes in one hand and takes another thing and he puts it there, he actually has a small container in his hand.
You say that he has a small container, but let's hold
Yeah.
on to that for a minute and ask a question and come back after a question. Okay, so how does the magician make the salt disappear or the liquid? A, he actually makes salt disappear and brings it back somehow. B, he wears a thumb cap and pours the salt inside the cap. C, he pours the salt on the ground. D, none of the above. You have 10 seconds. Okay, so we got our answers and they are all B's. So you all say that it's a thumb cap. Like, how do you know? Did you see it while he was doing the magic trick? Yes, Omash.
Yeah, as I said, he was hiding a container, but he was actually, I saw this illusions revealed the real thing what he does, and I actually saw the correct thing that he was like, he was actually putting a container and he was like putting a small thingy on his thumb and his nail, and actually when the salt gets in, it actually gets when the container does cannot hold too much salt and liquid. He actually what he does, he just in the what he puts in his thumb, he actually like somehow, I think so, the salt gets sticky on that and it sticks there, and somehow when he does that, it comes.
Okay, so you say that he has
Yep.
something on his thumb and he puts it inside his hand, pours it inside, and takes it back again. It takes a lot of talent, really. Like, he's just so fast. So now we got a slow motion video to see things more clearly because definitely it's hard to see. Okay. Pay close attention. So he pours the salt, blows it. Now we can't see it. Yes, that's a cap which looks
A fake thumb.
Yes. A fake thumb. That's true. A fake thumb that he wears on his thumb. And then you were right. He used exactly as a container and put the salt inside. But now we're watching a slow motion part of it, but he's just doing everything. So he put the cap actually back again and poured so the cap is there. Yeah. Isn't it?
Wait, what he does is, in the fake thumb, he actually puts the salt, and when he's revealing the salt come in his hand back, he's just pouring it in his
Yes,
hand.
that's true. But you have to be like super fast. Have you ever tried doing magic tricks before?
I know
Any of
one.
you? Which
I know
one? Which one?
I think so. This is not actually a magic trick, but yeah, I got it. I just have this, and I have more, but I'm just going to show this.
Wow, what's happening? Wow, Omash, what are you doing, Omash? You
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 can
just
you
Actually,
can
what I
you
did is I took one thumb, put it in my mouth. I just took another thumb and put it above it, and I hid the thumb I used before.
okay?
Yes,
So
perfect.
so what is this illusion about?
Nothing, just
Stretching your
thumb.
thumb.
Disappearing the thumb. Okay, thank you,
Yes.
Omash.
I used to try a lot of things about coins, like disappearing coins, but I never really worked on them. But yes, the important part is like while we were watching illusions, we somehow just like don't understand how they happen. But actually, it's a matter of being like fast, and they always have something hidden, like a little component that they use during the trick. So never forget that. There's no such thing as magic. It's just
Yeah.
science.
So this was the final question, and I am waiting for the results. But we have one little challenge for you guys. We have another experiment video. Professor Sunday shared it with us this week, and we wanted to share it with you. And there is this special challenge is active now in Twing mobile application, and the name of the challenge is find the balance with wooden sticks. We have one video of this nice little experiment that I will share with you now. So what happens in here, you find a rope, tie it to a water bottle, like 500 milliliters, and you have like 1.5, 2 liters of heavy weight, another bottle. You put the rope on top of the stick, and then at the other side of the stick, you put the weight so they stay balanced, and you use another stick and you connect 3 sticks together as shown in the video, like this. And when
Wow.
you take the bottle, the heavy one, away, you will see that everything will remain as is.
Oh my
So
God.
this special challenge is active now in Twing mobile application. But while we are waiting, we want to ask you guys, how do you think this
I know.
becomes possible? How do you think? Any one of you have an idea? Cameron, yeah, please go ahead.
So you attach it to a string, and then once you attach the two bottom bits, it just becomes physics where it puts all the pressure on those sticks, but they can't snap because it's on a flat
Nice.
surface.
Yeah.
So therefore it stays and can't move.
Okay. So Professor Sunday,
Yes,
was the answer acceptable?
yes. You want me to explain?
Can I?
I think Omash, who wanted to explain?
Me.
Me, you, Omash. Okay, go ahead, try.
Actually, what it's he just puts the bottle, and he just puts a random big bottle of milk or something, a juice or tank, whatever. And when he keeps like for 1 minute, 5 minutes, the force actually of the bottle is like pressure. The pressure of the bottle is actually on the sticks. So the sticks get attached to the table and they randomly balance the bottle.
Are you sure about this explanation?
Yep.
Do you want to consult to Professor Sunday, because his profession is about this?
Do you want me to explain?
Yes.
Yep.
Right. Okay. This is what in engineering we call it struct and ties. That's the engineering terms for it. But what is really in physics, what is really is force and reaction. Yeah. So we have a stick with a bottle of milk sitting on it initially, and then we have a rope that goes around it and suspend the bottle. So all the weight of that bottle is hung on the stick to start with. Yeah. And then when we go to the other side, we now have the rope is doing that. So that's the stick there, and the rope is doing that. So let me use a pen as a stick. Yeah, and the rope is doing that. Then we have another stick in the middle here. So there's a force of the weight of the bottle is along these two ropes here. But when this stick comes along, when this stick in the middle comes along, that force in those rope is now translate to the horizontal piece. Yeah, so that force is now in the horizontal piece. And then when you then put the vertical one, yeah, you can even see the horizontal piece is bent a little bit because there's a lot of force in it. Can you see? When you then put the vertical one in there, the force in the horizontal piece is now transferred to the vertical one. Yeah, so that first piece that's horizontal is actually being lifted up rather than trying to pull down. Yeah, so the force on it is actually trying to lift it up, and that's why it won't collapse. So if you look at the edge of the table there, you could see it's really fixed onto the edge. So it's leaning against the edge of the table. So there's no way it's gonna fall. It doesn't matter how much force you have in there. Yeah.
So
I
this is
think
a
so.
very,
In the table which they're putting the things, the stick and all.
Yeah,
I think so. The table can lift the weight.
It's lifting at the back, but you could see the front of it is reacting against the table edge. And because the force in the vertical one is pushing that stick to react against the table edge.
Yeah, because it's like lifting because the more part of the stick is on the table and the less part of the stick is on the outside.
Yes, you could say that.
So it's trying to balance.
Yes. So basically, what you have in there, if I could demonstrate it, what you have in there is like so the vertical stick, the horizontal stick, and the edge of your table. So it's basically like that. Yeah, and it's stable. It's in equilibrium. Yeah, the only way that thing will fall if you remove the table or if you remove the front stick. Otherwise, it's sitting in equilibrium.
it is like you extend the table, like
in a way.
Yeah, in a way. So where do we use this technique in structures, Professor Sunday? Where do we use this technique?
Yes, we use it. We use it quite a lot in bridge design. Even ordinary shelves in your home can be based on the same principle, which is a picture that we showed earlier. A little shelves with a hang on it. We have a tie and then we have a strut. It's the same principle. It may look upside down, but it's exactly the same principle being illustrated in there. So when you go around anywhere, look for strut and ties. They're all over things that we use, play with. Even some of your toys may have that principle right there, but you don't notice it because you haven't seen it being explained to you like this before.
Okay, perfect. So we got the winners of the day, the winners of the day. I will announce their names right now. And before that, maybe we can evaluate the session, Lara, with the co-host.
Yes. Which question did you like the most? Indrajit.
I like the illusion one. I found it quite interesting because I didn't.
The camouflage.
Do you like the camouflage? You like the illusion. Ali?
I like the camouflage as well.
Okay. Vasisht?
I love the camouflage one.
Mantis was really good. Cameron?
Yeah, because I couldn't even notice the mantis.
Yes.
Couldn't even notice it.
Yes.
You
Cameron?
have to have a laser eye to be able to see that. Even I did not see that.
Yeah, me neither.
I like being a part of the nature.
That's what actually camouflage is.
Yeah.
Cameron, finally.
I like the illusion one because it was
Like
quite
it.
fascinating to see how he did it.
And he was acting pretty fast, right, Cameron? He was acting pretty fast. He was taking the containers, switching hands, and like pouring salt and
So the
liquid.
audience couldn't see it.
Yeah, the audience couldn't see it. But Omash catch the trick, right?
Yes.
Because Omash
Even
has very critical
even
eyes.
the judge sitting in front of him couldn't see it neither.
Yeah.
He does it very, very fast, and he's the only one that knew exactly what he was doing.
Yeah, so the like magicians are the very talented people who perform with the law of science, guys. Okay,
That's
any
right.
magic trick is has something scientific behind it. So they are actually the scientists back then, maybe 100 years ago, when they find something, people were surprising too much, so they were demonstrating their, for example, discoveries about electricity. But no one have ever seen a lamp before. No one has ever experienced how electricity is being transmitted. So that looks like science. That looks like magic to those people. But especially these people are very talented using in scientific techniques for their performances. So we thank them, because my childhood, I was watching their shows and trying to figure out what is the reason behind it, how this can be. And these are the two winners of the day. We give them a big applause. Danush Tajanish, Barış Falay, and Defne Merve Keçeci. Please follow Twin Science Instagram account and send a direct message with your YouTube username. And
You know what? You said right. The people before who didn't know electricity and all, the ancient people and all, the ancient Greeks and all. They actually learned from the archaeologists who came. Only most of the people, because some people don't live for long time.
Yeah, definitely. So we look for the sign, and archaeology is another scientific area that helps us to understand our ancestors, and help us to understand our position in the world. And each archaeological site shows another thing about us being part of the world. Okay, part of the ecosystem. As Ali said, mantis is very powerful while going in harmony with the nature. That's what we should do. We should respect the nature, and we should respect science, and be aware of the climate change and the endangered species in the world. And we should act responsibly, and we should do our part. And by attending today's show, yeah, Professor Sunday.
Yeah, I just want to show a little magic before we go.
Yeah, of course.
Right. I'm sure some of the kids in Africa will probably know this magic. Can you see that piece of paper? It's on my third finger from there. Yeah.
Yeah,
so
we definitely see it.
Yeah, and you can see here it's on the for me it's on the right. Yeah, and when I do this, it's gonna be on the left.
Okay.
I'll do it next week.
Okay. So we will record this video, Professor Sunday. We will show next week.
We will record it and we will record it and send it to you.
Yeah. And
I did that badly.
we will show that you need to practice to make better, right?
Yeah, be more fast next time.
Can I show one?
Yeah, sure. Why not?
I actually practice this. I actually don't know how to do it, but I just
You just try. We have 1 minute for you. Yeah.
Oh, yeah. Wow.
What's happening? It's confusing.
it's
You're
like
too close to the
the
camera.
this thing is going inside the palm.
Yeah, it is nice. Okay, I got it. I will practice it and show it at the beginning of the next show. And please, if you want to be a co-host like Vasish, Indrajit, Omansh, Cameron, and Ali, please send an email to hello@twinscience.com and write who wants to be a twinner co-host in an email subject. We have co-hosts from all around the world, and we love to see you guys in this show because you make this family very valuable for everyone. So we thank you.
Question:
Yeah, Omash, please do.
Can I be the course again?
What?
Can I be the course again?
Yeah.
Of course, you can. Please send us another email. But priority is to ones that are not that are not
Here before.
here before. So if we don't have any priority, we will have you again. So thank you guys and see you next week. STEM number 8, I believe. So have a nice day.
Thank you.
Thank you.
Bye.
Bye, everybody.